Right then guys, what I'm going to talk to you quickly now is about fall-arrest blocks. The way it's used, and we've done extensive testing on the blocks, okay, which you'll see later on in this DVD. As you can see, I've got one inertia wheel there. I've anchored it around my column and I'm going to go to work in the direction. Now, the key points that we found from our testing is number one, when using one inertia wheel, the block must be anchored directly behind you. Okay, so then when I'm actually going to work, you can only work 1 metre either side of that anchorage point. So let's look at now attaching to the blocks and what the testing has proven, okay, to the way we use these blocks. Now I know you guys out there haven't got dyneema tails, and attaching an inertia wheel straight to the dorsal plate and the D-ring of the harness is a nightmare. So what you guys are doing are attaching shock absorbing lanyards and then attaching the inertia wheel to the shock absorbing lanyards. Now guys, this is so dangerous. Number one, you haven't got the floor height. So what I'm saying there is if you fell, it's like you've got nothing to stop your fall. You will hit the deck. Number two, if your shock absorbing lanyard starts to deploy, the tearing process that happens to slow you down in the shock absorbing lanyard produces what we call resonance. Now resonance is a vibration that travels up the harness, okay, into the inertia wheel, and it turns the brakes off. So you should never use a shock absorbing lanyard to attach to an inertia wheel. The second reason we've put dyneema tails on here is because when you guys do attach straight to the D-ring, when you fall, the actual carabiner of the inertia wheel lands on the slab edge, and we'll prove that to you when you see the testing part of this DVD. It goes into shear and the gate fails. So that is why it is so important, guys, to use dyneema tails. The reason this is, one, we can see that what we're attaching to. Okay, so I'm attached there, and if I do fall, the dyneema will take the shock of the fall from the edge of the slab. So now, what I'm going to do now, guys, is I've attached, I'm going to move forward, and I'm going to go to where I need to work to. So guys, I've attached to my inertia wheel, I'm just going to move forward now to where I need to work. So, I'm on the edge now, guys. My anchorage point is directly behind me. I can now only work 1 metre either side of my inertia wheel. If I come to mid-span, which is more than 1 metre, guys, I'll tell you what, you might as well take this off, let that go back there, and jump. Because as testing's proven, guys, you just hit the deck. So you might as well work there with nothing on. So the key points I'm trying to make to you guys, okay, is number one, 1 metre either side with an inertia wheel, one inertia wheel. And when you come and do a course by leading edge, we'll show you ways to get around that by using multiple blocks. And the inherent problems that we do have with that, i.e. you can only have one person working in that area. On this diagram you'll see that the guy's gone to work with his inertia wheel, he's gone to the front column and attached his inertia wheel at the front. Now working like this, guys, means that you cannot come past mid-span because of the pendulum effect if he falls. On this diagram you'll see that the guy's actually thought about what he's doing. He's gone 1 move back, but he's still using a single inertia wheel. So he still now cannot go past mid-span, okay, on the diagonal, because if he was to fall, he would still go into pendulum and he would still hit the deck.